Okay, we're live. So welcome to live app review episode something. I don't know which number. We're going to be talking about user onboarding again. We've got Eugene and Aaron joining us. So let's just jump in. So I was given an interesting challenge from Ilya recently, just 3 hours ago. I think I actually edited it 3 hours ago, but he posted this yesterday or last night. So we want to kind of survey some of the different onboarding methods for users. So one is the sort of the access key account, which you've seen several times in live app review before. So this is where the user comes to the app. They have no Near wallet. They don't have any Near tokens to pay for gas. And the app essentially gives them an access key on the applications contract. So the app lets a key pair that can be 100% non-custodial generated on the user's device. The app adds that key to their smart contract, which allows the user to do a limited set of things, like a limited functionality, because that user is not they're not interacting with that contract from their own account. So they're basically kind of like a sponsored user at that point. So that's the access key account. The managed account is kind of an interesting pattern. So it is basically where the app has some account, let's call it app.near as it's written in this example. I'll zoom this up a little bit. So this is the one we're going to look at, kind of like a variant of the managed account today, and maybe try to combine it with this access key pattern, but I don't know if it's going to work. I have no idea. Eugene probably knows right away whether this is going to work or not, but we're going to try to find the best possible way to kind of build it, or we're gonna modify one of my existing sort of access key onboarding patterns to make it work. So a managed account, what is that? That is basically where the app has app.near, and we need to bring new users on that can receive tokens and make NFTs and do things. And we want those users to own those things. So let's say the user Ilya wants to create an account on this app. The app would create ilya.app.near. But of course, ilya.app.near, it can be created as an account on the blockchain, but the app doesn't necessarily have to create it right away, because app.near is the only account that could ever create ilya.near. So for example, they could create it kind of on their back end. So they could basically have some backend database or service that reserves it, or they could create a mapping, which is what I really want to try today, a mapping from a specific public key that the user owns to the username Ilya, and then combine that with the fact that we're inside the app contract and basically just look up the user or by username. And then later we could fully create a sub account or transfer all the assets. And yeah, that's about it with a managed account. So basically the app is managing these sub account names. The reason why I would like to explore that is because in the access key account method, you really only have a way to identify their account through this hex public key. So it's a special type of account called an implicit account. So, but with the managed account approach, it seems as though most people are doing this, and it's a custodial account. So what we'd like to do is basically create some sort of a named account, but then instead of having it be managed by the app, we'd like to make it non-custodial. So I'm not even sure if this is possible. I'd like to actually maybe kind of quickly ask Eugene, what do you think about this approach, sort of like a managed account? And would it be possible for us to name an account, create a username for an account that was essentially managed by a key pair that was talking to the contract? So it's been added to the contract as an access key, but inside the contract, we obviously want only that key and not the actual, like the master key of the app, to be able to move assets for that user.
Yeah, I'm a little confused on this still. So do we create the actual account, or we don't create an account?
I think what we're talking about here is maybe not creating the account, but just using for some reason, using the sub account naming convention. I don't actually know why this is being used.
So this is important because so the reason for this is like you actually need to have an account naming, because only the app can create this name. So basically, once you start onboarding, you don't create an account yet for the user. You do the onboarding through this implicit access key pattern, except you don't create an account at all. So what you do, you have a public key pair that you generate on a user side. On a browser side. Now you have the public key, you pass it to a backend that will create a limited access key from like some of maybe the contract itself. You restrict it to only do actions that you want to do by the user. So let's say you want to like interact with the app. Now, when you are in the contract and you see you're getting called either by self, in this case, I don't like this pattern as much, but maybe you can create a separate account for just this type of stuff. So let's say you have account that's called app.near. So this is our main contract. And then you have sponsor.near. So this is the account that will cover the gas. So you add an access key to the sponsor.near. And when sponsor.near calls app.near, you know that this is an implicit access. So now you map a public key from app.near to the username that you want. So for example, you can associate this with ilya.app.near. That allows you to later, when ilya.app.near arrives, all the assets within this contract are already associated with this particular account. So again, we don't create the ilya.app.near account yet. And the reason for this, we don't want to spend real tokens on this. We only want to spend gas on this. Then once ilya.near or ilya.app.near earned enough inner near tokens that we are ready to create the account, we can do this because internally we reserved this name already in some map. Does this make sense?
Yes, it's how I thought of it. The specifics of, so I understand the reservation part of the name, and that's because of the way that sub account names are granted. So just a quick recap for anyone who might be listening to this later, who doesn't have the depth of Eugene's knowledge with respect to you know, the protocol and the contract runtime. The like every account on Near, for example, an account called, you know, app.near, literally somebody who owns the account ID app.near. They are the only ones that would be allowed to create sub accounts, names like eugene.app.near or matt.app.near. So because app.near is the only account that is able to create those sub account names, we can safely create a contract that maintains a mapping of some public key to some sub account name. So for example, if I have a public key that I'm using to interact with the app, app.near could create a username for me and reserve it as, you know, this public key. When it does transactions, it's going to be referring to the username Matt. And therefore, when I've earned enough Near tokens to actually purchase my username for this app, to actually reserve it as a full account name on the Near blockchain that anyone can send Near tokens to or whatever, then it is safe to assume that that name is reserved for me, like matt.app.near. Is there anything else you would add to that, Eugene?
No, I think that's pretty much it. So we basically using the fact that only the app can create a sub account, so no one can snap this name and claim the assets. And
right,
we internally reserve this name towards this public key, but we don't create an account yet. And when the user actually ready to create an account, this is when we create it and spend tokens and give the ownership back to the user. For now, we're paying for gas from either our app account or sub account. It's easier to use sub account to avoid like some private methods if we have callbacks.
so let's talk about custodial, non-custodial for a second. Let's explore a couple of different things. So we said here that we're using the fact that only the app can claim the name on behalf of the user. Okay, that's great. But couldn't the app, so let's say the app says that in the future some name is going to be created, you know, so can you, first of all, can I send Near tokens to matt.app.near before the account is created, before the account is named, or would that just fail?
No, it doesn't exist. So if you send it, then it fails. What you can do, you can kind of create this account through the app. So like through the contract. So you can send it to the contract and say, well, actually, I want to claim my account. Here's like the balance needed to create this account. And app will add this access key that you have on associated with like your username to like create this account. So there are some challenges like wallet onboarding because of it's not an implicit account, but you probably can recover it somehow if you can pull this access key.
Okay, that's great. No, this is good. So I guess then what I wanted to talk about was that is there anything, so let's say we had the wallet onboarding that we wanted. Let's say we could have any wallet that we wanted and let's ignore the official Near wallet just for the moment. In the example that I created, I had this only owner method. So this is a smart contract that has some basic NFT functionality, and I protect certain methods with only owner. So, for example, the transfer of the
We
NFT.
actually see your browser GitHub page.
Sorry,
No,
beg your pardon?
we can't see your ID.
Oh, you can't see my IDE. Oh, hold on one sec. Sorry, I selected the wrong window when I shared. I was just looking at my IDE. Okay, I'll just share the whole desktop. There we go. Okay, you can see it now?
Yeah.
Okay, well, for everyone that couldn't see it, I was writing notes the entire time. Sorry about that. But basically, how I handled this this sort of onboarding with the access key before. So there's this demo, and you can come to the demo and you can say you want to sign in as a guest. And I will leave that up to the application developer to choose how they want to authenticate the user. But basically, you know, given some sort of probably OAuth or some email verification or something, the back end of the application would create not create, actually, would simply just add the public key of some key pair that only the user has to their app account. And then every transaction that kind of goes into this contract can be looked at to see whether the signer of the transaction is in fact the account ID. So this is really like a misnomer. This should be, you should pass this in, and you're basically trying to match it up with what you would refer to as the owner ID. So basically, this is like a modifier on a method to panic if the person signing the transaction is not the actual owner of the asset. So for example, like an actual Near account making the transaction to the app account itself. So account ID, you know, matt.near is signing a transaction on app.near. But if it's a key that comes from app.near, it's going to try to, so in that case, this would fail. It's going to try to look up the implicit account from the public key that signed the transaction. And in that case, it'll match that. So what I'd like to do is ask ask Eugene, is there a way to do this non-custodial approach, except instead of mapping to an implicit account ID, could we not simply recover the public key, go to a mapping that is inside the app contract to username from public key, and just say, hey, we found somebody here, let's, and they happen to be the owner, let's go ahead and let's give them the asset, or let's let them do the rest of the function.
So I would suggest to do this the following way. You can introduce a function, something like get account ID or like resolve account ID, that is looking at the predecessor account ID, and if the predecessor is sponsor.app, so like your sponsor app or sponsor contract, sponsor.near, then
right.
it looks at the inner mapping and convert it to a potential account ID. So at the end, you don't have to work. So basically, you can change predecessor account ID to be like resolve predecessor account ID. Like, and this way, you only once doing this casting, right?
So what you're saying is you're going to say if predecessor is sponsor, whoops, sorry, JavaScript land, sponsor.near, So basically some other, so could it not be this? Could it not be like that?
Yeah, it can be.
Yeah. So then you're gonna, check username mapping with the signing key, right?
Uh-huh. Yep.
Because, okay, so now wait a second. I just want to make sure I understand this correctly. The signer has made the signing public key has made are they making are they calling a function on sponsor.app.near?
No, they call it on this account.
They call it on this account. So this account being app.near, right?
Yeah.
So how does the predecessor end up being sponsor.app.near?
Because they initiate the transaction. So sponsor.app.near is the account ID that holds this temporary public key. So we don't want to put it on our contract because it will mess up the storage and like it needs to properly manage this key.
Okay.
Plus like balance will decrease of this app. So we don't want to like even mix them together.
So the user's key is added to sponsor.app.near.
So okay, yeah. So here's how you do this. Like, let's say you go to the app first time and it's like says that you are not, and you click login. So maybe it makes a model window that's saying, I do want to use your Near account. Like, do you have a Near account? Then you can directly proceed to the wallet and you use a regular flow. Or you say, I don't have a Near account. I would like to like try the app. Then it asks for your user name, which has to be unique within the app. So it cannot be, for example, Matt, if you already have Matt in the app. Like you cannot create a second Ilya.
Yeah.
And you cannot create sponsor because it also. So you pick, for example, Eugene. What happens is your backend has to do two things. You need to add this access key to sponsor, but at the same time, before this, you need to associate this public key in the app.near to Eugene.app.near. Make sense?
Yeah.
Yeah, that's pretty much it.
And is that sorry, that mapping happens in app.near, right?
Right. So the limited access key that you add to sponsor.app.near, the receiver of this is app.near, which means it can only call app.near. So essentially given like 0.25, for example, near in allowance to use the app. And then the predecessor will be resolved to be your username. So then you just need to like you use the app regularly, like you kind of this get account ID can be renamed to something like implicit predecessor or something like this. It's kind of like a predecessor, but you don't actually assume it.
So I guess what I'm struggling to understand is if you add the public keys to the access key to sponsor.app.near, then the user has to make, oh, no, sorry, I get it. So you've added the key to sponsor.app.near, right?
Yeah, yes.
But the it's an access key with a receiver of app.near.
Yes.
So what you're saying is you're saying that the predecessor account, essentially the account where this access key like originates from or lives in, is sponsor.app.near. So that'll be the predecessor.
Yeah.
So what would be, at this point, what would be the signing account ID? The same, right?
Yes. Yeah, it will be sponsored.
So predecessor, so this is not in fact a cross-contract call. It's a call directly to app.near.
Yeah, but we want to rely on predecessor because let's say this app also can handle cross-contract calls. So in this case, we need to rely on predecessor.
Right. Could you explain that a little bit more?
Yeah, so for every contract, we usually want to handle two incoming receipts. It's either a direct call, which is a transaction that originates from the account of the user and goes directly to the contract of the application. So this is when you use the front end, you like click on a button, we call this contract from your account. So this is a regular user call. But what we also want to do is programmatic way of accessing this contract. So let's say I wrote a bot that reacts based on what you did in different applications. So then I will interact with the bot, but bot will make a cross-contract call to the app. So in this case, signer account ID going to be Eugene, but the predecessor is bot. So if you use a signer account ID, you can fake like this is direct call from Eugene. So that's why we always use predecessor instead of a signer. So, and because sponsor app.near will never do a cross-contract call to app.near directly, it is safe to assume this is a signer as well. So like if you rely that sponsor.app.near cannot be a proxy. Anyway, so that's like more complicated explanation.
No, that makes sense. Yeah, I'm just trying to separate. I think the real light bulb for me went off when you were describing the sponsor.app.near approach. It seemed a little bit like sort of added complexity, but now I understand the use case of, okay, we don't want to sort of mess up app.near by adding a bunch of keys to this contract because we have no idea what's going to happen with storage and you know things could get out of control, right? Especially if we're onboarding like lots and lots of users. So keeping all the users that are sort of sponsored, but then with the intention to upgrade them and to delete the access key and get them to move to their own account in sponsors.app.near is better. The real key for me was when you sort of like, well, in you talking, I sort of thought to myself, okay, there has to be like this can't be a cross-contract call. Like you can't have, like you must not have to call sponsors.app.near. That's a bad pattern. So basically what you're proposing here is it's like an upgrade by putting the keys on sponsors.app.near. You don't have to do cross-contract calls because you basically are just calling app.near. You can make a special helper function called implicit predecessor that has the same logic. I don't have to change this logic, right? Like this is relatively okay. And as long as there is if predecessor equals sponsor.app.near, we just do an additional sort of check, right?
Right. Yeah, and then you just return the, like, if it's a sponsor, then you do the mapping. If not, then you return the predecessor.
Yeah. Okay. So it would be like, you know, self.accounts.get, and we would just look it up by the PK, right? And then,
yeah.
you know, we would, I
Yeah,
don't
you can
know if
unwrap here or like expect here because
expect, yeah,
you,
okay. Expect to like no account. Okay, and then if we
otherwise you like, so you return the account ID from the body of the if met, like if check. So you just return it, and then else you return the predecessor.
yeah, wouldn't this just return right away like this?
No.
No, not from an if. Yeah. I'm still
Well, if you
becoming
do
trying
else,
to
then it will
become,
do. No. If you do else, it will be
it'll
correct.
be okay.
Yeah.
All right. I'm learning the nuances of the Rust way. So something like this. Okay.
Yeah. So this is step one, right? And it all good except the final case when you actually handle transfers to predecessor.
Right. Yeah. So how do we, so let's say somebody wants to send tokens to eugene.app.near, right? So
Yeah.
they could be sending fungible tokens, they could be sending NFTs, they could be sending near. What do we do? How do we handle it?
So the account doesn't exist, but within this app, we kind of pretend it does. So no one else will be able to send anything to this account except for this particular contract. So let's say this is an NFT contract. It means the account internally owns these NFTs already. The problem is you the problem is you cannot really so you can only redeem near. So let's say you want to redeem near, like you sold the NFT that you created in this app and you have 5 near. So this is what you did in a previous example with implicit account ID. So you just directly transfer to implicit account ID. In this case, you have to do the following check. Before you transfer, you verify, is this an implicit predecessor or a real predecessor? And again, you can do the same check that you did before. So if predecessor is sponsor app.near, it means this is an implicit predecessor. We cannot really send near to the current account ID. Instead, we should create this account ID, remove the keys, and that will be the moment when you create this account.
I see. Okay, so there could be an option. So let's call this optional. Near is transferred to a payable method that I'm just going to write resolves the implicit predecessor. Just wait. Predecessor of the receiver. And then we would create the account. So, you know, unique.app.near and transfer the remaining near tokens to it. Something like that, right? Like we would have, so let's say within an application, there was a button to transfer near to another user in the application. Okay. But the other user is not, they're not real. They're just an implicit app account. not an implicit near account. So I want to transfer them near. So I say I want to send them 5 near for their awesome NFT or whatever, right? There's a payable method, obviously, that captures my near. Then we go and we look up, oh, you know, what kind of an account are they? Oh, it's an implicit predecessor account. You know, some account that's been sponsored that doesn't actually have any near, it doesn't really exist. So what we do is we take the deposit and we kick off a method that creates that account for that person, takes their public key, adds the public key to that new account, deletes them from the mapping of the implicit accounts, transfers the remainder of the near to that account, and gets rid of them. Gets rid of them from the implicit account world. Now, the next time that user logs in, or if they're just sitting there on the app on the receiving side, they simply, the next action that they take, they're going to see that they have, not only do they have a real near account, they have a balance. And when they go to click transfer, they're kicked off into like a real near, you know, send money, transfer funds flow, because they actually control that account, right?
Yeah, that can be one flow. Another option, you just internally give them near in this account. So the contract keeps the near for the receiving implicit account, but it has the map saying like how much balance the implicit account has.
Yeah.
So then the user comes in with their access key to claim near, and they see, oh, I have 5 near. Do you want to claim it? And the reason why maybe this flow is better, because they need potentially create a new key pair. Right now, they only have the access key from sponsor.app.near, but they actually need to move this access key to the wallet. Like they somehow need to import this account into the wallet.
Into the near wallet, you mean?
Into the near wallet. The way we usually do this is there's some like URL where you can pass access key directly, and the wallet will just replace this access key with the new access key that you back up. This is how we can potentially do this.
Sorry, could you repeat that one more time?
So when you click claim near, but you don't have an implicit account, so what you have is a key pair in the browser, but not in the wallet.
Yeah.
That's not very secure way to own an account. And your options are you basically want to somehow to transfer this key to the wallet.
So I have a suggestion. What if the original app account that you created was created with a seed phrase that was presented to you when you signed into the app, and you wrote it down somewhere, and then this app key sat in the local storage of the app. So yes, I do understand the insecurity of that, but you are being sponsored. So then you receive near tokens, and you have decided that upon receiving near tokens, you automatically want your app to be, your name to be created on the near blockchain from those near tokens. And you take that very same seed phrase and you take it to the near wallet, you put it in, and boom, you're in the account.
The problem is your access key that was previously only limited access key. That's why like the security of this may be not as critical. Will now be a full access key to your account. Maybe this is not what you want.
Exactly. Yeah. Yeah. So that's security.
That's why you don't want this seed phrase what you can really do is you go to the wallet, you create implicit account ID, and you have a public key for this account. So you can now use this public key to give it to the app to create an account. So when you click claim, somehow it receives this public key from the wallet, and it does the following. It creates account ilia.app.near with two keys. One full access key that it got from the wallet, and second is a limited access key that points back to the app.near with the same key that it was previously from sponsor. It achieves two things. Wallet, which you securely backed up either through Ledger or like from seed phrase or like any other option that we have on the wallet, will be able to discover this account by this this public key. So it will kind of import it automatically to your list, which it doesn't do automatically yet, but it can. And second, you can continue use the app immediately without having to go to the wallet because you added a restricted access key from the new user ID to with the same key. So you have this key on the front end of the app, the private key.
I think you're going to have to walk me through that just one more time really quick.
Sure, let's do this. So when you see you have 5 near,
yes,
the app saying something like this. Hey, go create an implicit near account, which is free, and back up the seed phrase that you will have like securely, like secure this account.
Yep.
Then it does the following. It does sign in with wallet without creating access key, right? You can do this, which is a proposal. Kind of right now you cannot do this, but let's say you can sign in with wallet. All you need is to get this implicit account ID from the wallet. Once you get this implicit account ID, you can convert it to a public key on the front end. So now you have two public keys. Oh, you have old key pair, which is both public and private key that you use to interact with the app. So it's restricted key pair. And you have a new secure public key, but you don't have access from the app. Make sense so far?
Yeah. So you make two keys out of the new implicit account ID.
No. You already have one key that you used before.
Yeah.
To use the app. So let's call it key 1. So key 1 is the key that was created to use the sponsored account.
Okay.
And key 2 is implicit account ID key. So this is, so the second key, the application, it only has the public key. For key 1, you have both public key and private key on the front end. So the front end only has public key for key 2 and both private and access, private and public key for key 1.
Okay, so exactly. So when you say you want to claim, when you say you want to create account and claim, instead of moving over the original sponsored access key, you're just gonna delete all of that implicit predecessor key to username stuff. You're gonna get rid of all of that from contract storage.
Yeah.
On app.near and sponsor.app.near, you're gonna delete the key and stuff. And then what you're going to do is you're going to create the account and add the public key of key 2, which the app should not have any
yes,
access. It doesn't even have the ability to access the private key.
yes, but you're also gonna add another access key, which is key 1. So you add both keys to the new account. One of them is full access key. This is key 2. Yeah.
Yeah.
And key 2 is full access key. Okay,
Yeah,
so here's what you achieve. On the front end of the app, you can now change your previous access key that you had that was coming from sponsor account to your new named account. And it means you don't need to reauthorize the app. So you don't need to go to the wallet again.
Right. Yeah, I think I understand. Hey, I have to run because I have a talk. I think it's in CryptoVoxels /Discord. So I don't know how to get in there, and I have to be there. And
okay, yeah, I mean we mostly done. Just don't forget to like clean up the storage in this process. Just
yeah, thanks for your help, Eugene. Like I'm definitely trying to make this. I'm trying to make these patterns a little bit more official and a little less hacky than my examples. But my examples are really just to get people aware that we can do interesting things here. But your feedback is much appreciated in making it sort of a reality. Are we even recording? I hope we're.
yeah.
We're recording.
Okay. And thanks everyone for tuning in. Sorry that today was much more of a kind of a whiteboardy sketch with me and Eugene with regards to these onboarding patterns. We're still figuring out the exact kind of like details of what would be like a good experience from both the developer's point of view and the user's point of view. But thanks for tuning in.